In this video, we're going to be implementing this. So you may know it as a object, or maybe a map, a dictionary, or sometimes a hash table. They're all basically the same thing. And how they work is you can pass in a key. So I called this first name. It's a string, and then you can store some values inside of it. And so I can also put multiple keys in here, so first name and last name, and I have the two values stored there. And fun fact about this, the way this is built underneath the hood is actually with an array. So really this is just an array with some different functions on top of it. So in this video, we're going to look at how exactly you can make your own version of this, and we're going to see how it works underneath the hood. Now, to follow along with this video, you have two options. One, you can have Node.js installed on your computer, and you can just run Node on the JavaScript file that we create. But for this video, if you want, you have a second option, which is what I'll be using. I'm using this plugin called Quokka, and what this does is it allows you to execute or see the output of code as we write it. So for example, if I do a console log here, person last name, oops, there we go. You can see I can just see right here on the right that Bobby is the key for it. So it's very nice for quickly prototyping and creating stuff. So once you install this extension, if you want to use this, all you have to do is hit Command-Shift-P if you're in VS Code, and then you can say Quokka new file. And so I'm going to pick JavaScript, and this is where we're going to start. So I'm just going to close this. I'm going to save this file, and I'm going to call it hash table. So the first thing that we're going to do is create a class for our data structure. So I'm going to call mine class hash table. And then inside of this, we are going to do a couple things. So I'm going to first spec out the API. So we're going to have two functions that are going to be available. We're going to say get item, which is going to take a key, and it should return the value. And then we're also going to have a set item, which has a key and a value as a parameter. And then here we're going to say some kind of value to set it, or put some logic there, I mean. And then down here we can actually call this by saying my table is equal to new hash table. And then my table at set item. Here I can put, for example, first name and then Bob as the value. And then we can look this up by saying get item. Like that. And it looks like Quokka is not actually running. But if we console log my table, I'm just going to restart it. You can say start on current file. And it should output now. There we go. So my table.getItem here is what I want to log. So when we've done this correctly, this should print out Bob as our string. All right. So I told you that our hash table up here is going to store stuff in an array. So let's create that array which we're going to store stuff in. So we're going to say table is equal to. Now usually you create arrays like this, but we're actually going to say new array because we want our array to be a certain size to start off with. And so this number we're going to start off with just as 100, but this is something that we're going to come back to because the number you pick for this can be useful or important. All right, so for our set item here, we want to be able to store this key in our table, but the problem is arrays, we can only index. Like I can only say table 5 is equal to something. I can't say table hello or something, a string as the index here. So we need to turn this key into a number. So usually you'll create something called a hash function, which we're going to say hash string to int. And this is not really specific to our class, so we could actually just put it in a function up here if we wanted to. So we can pass that up here. And then we can call that function. So then what I could do here is I could say hash string to int, pass in my key, and that'll give us an index. So let's actually split out like this. Index, and we can set the value like that. And so up here, we just need to pass in, here's a string of some sort, and we want to turn that into an integer. So one way we could turn this into an integer is we could just return 5. And that's one way we could do it. And then down here, and by the way, I'm getting tables not defined when we call set item. I'm going to say this dot table. So we reference the table that it's inside our hash table. And then to get the item, all I'm going to do here is I'm going to say this dot table, and we're going to get the index for this key. So hash string to int the key, and we're going to look it up at that index. In this case, we're just hard returning or hard coding the number 5. But we're going to save this, and notice it works here. We set the item for Bob, and then we can get the item. The problem is now we've only done this for a single key. All right, we kind of hard coded that value in. So if I were to set a last name item to Tim, you'll notice that we got the last name here, Tim, even though we wanted to get the first name. So what we need to do is we need to get this hash function to actually spread out the keys and store them in different values in the array, not just position 5. So one way you can do this is we can loop through the string, and for each character, get the character code. So if we can say let value, or we could call it the hash, equal to 0. I actually don't know what you usually start the hash at. Maybe you start at a prime number probably. So I'm going to pick 17. Because one thing you'll notice with hash tables, I'm going to just close this also down here. One thing you'll notice about hash tables is you want to pick prime numbers for stuff because it will spread out where the keys are stored. Alright, so we are going to return our hash when we're done. And we're just going to say for let I is equal to 0, I is less than s.length, I++. And then we're just going to say hash is equal to hash times, and then we're just going to pass in our character code for the current string. So we're going to say s.char, and I just want to get some auto-completion here. So .char code at. Alright, so what this function does is if I have like Ben here and I say the char code 0, what it's going to do, and actually why don't we just show that right here. Should print it out, I think. Console.log 98, and we can do 1 and 2. So you can see what it does is it takes the character at that position, and it's going to give us an integer value for that. It's a representation of it. So now if I do that up here, char code at, and we pass an I. So if we were to do this with Ben, it would have B as the first value, and then E, and then N. So it would turn each one of those integers, and it's going to multiply it times our hash here. All right. Now you'll notice one thing that's going to happen is our hash is going to get really big. It's actually going to get too big for our table doing this. So what we need to do is we need to mod this by the size of our table. So table size. And we're going to put parentheses around this. So we just need to take this as a parameter now, table size. And let's pass that in here. So I'm going to say this.table.length. And we'll do that down here as well. Alright. Another thing is usually I see with the hash function is we'll have some arbitrary prime in front that we multiply this by as well. So like 13, for example. And so these are just two arbitrary primes I've picked. And this is also just kind of an arbitrary hash function that's very common that you see. But there's a ton of different hash functions you pick, and how well your hash function performs or spreads out evenly the numbers it gets is very important. And this will give you better performance and better, well, performance speed are the same thing, but it's going to spread out the keys in your table. So that's a very important, is the hash function you pick. But this should now turn our string, our key value, like first name, into an actual integer. And then that integer is going to be the index that's going to be stored in our table. All right, so we have Bob stored for our first name now. And so now if I get the item for the last name, we see Tim there as well. And all right, so let's just go back over what we've done so far. The main thing that's how we're getting this to work is we take our key that the user passes in, so the string, and we just turn that into an integer and we store that into an array. Now the other thing to note is we can make our table here like 113. I actually don't know if that's a prime number. We'll take 17 again. So here it's a good idea to put a prime for your table too. Usually just put primes everywhere from what I've seen. And this will give you a nice spread of your keys. Now I've said spread of your keys several times. Why do I keep saying this? Well, you can actually collide. So it's possible that we have two keys that go to the same place. And so one way I can demonstrate this very easily is if I reduce our table size to 3 characters, or just the size of 3. So if I do this, and let's say I try to set the item, alright, so let's set the item 4 times. So we have first name, last name, age is going to be 5, and date of birth, DOB, is going to be 1, 2, 3. So what you'll notice here is now the first name is printing out the date of birth. That's not good. So we have a collision at this point. And if we console log our table, we can see this. So my table dot table, and we only have 3 places in our table, and you'll notice that the first 2 indexes are used, and so these keys are colliding. So when we hash these keys, they both want to go into position 0, and so they're colliding and they're overriding each other. So that's a problem. So we need to handle this case of collision. Now we can avoid collision if we have a good hash function. So that's why the hash function is important. But what do we do in the case of a collision? Well, right now we are kind of just storing the value directly in the table. Now there's several ways to handle collisions like this. The first way we're going to do, or really the only way we're going to do it in this video, is by a term called chaining. So what we're going to do is, instead of just storing the value when we set the item, what we're actually going to store is an array. Right? So something like this when we set the item. And so we're actually going to store it like this. So we have an array here, and inside of that we have a key value pair. So we can look this up. And so if we have a collision and 2 guys are in the same location, it'll look something like this. So what I want to happen, and actually why don't we just implement it and you'll see what it looks like when we do this, because that'll be the easiest. So what we're going to say here is, if our table already has that index, so this dot table dot index, so is there, we're checking if there's already a value in our table at this position. If there is, we're going to do this. We're going to say push on this key value pair. Otherwise, there's nothing at that position, so we are going to pass an array with an array inside of it. And so that is going to change our set item, which is going to affect our get item. So now when we get this position, we have to dot find where the first element of the array is equal to our key. So what's happening here is we find the location, which is going to now give us an array because of how this works. And we don't really have a error catching right now if, for example, this does not exist, but we're assuming that we're getting an item that exists. We could add a if this dot table idx, this does not exist, then you can return null, for example. You can add a little error checking. Alright, so otherwise we are going to loop through the array and find our key. Alright, so let's see this in action now. So we're going to comment this out. But you'll notice now when we get the first name, last name, oh, we get in this. So when we find the element, we then need to get the the second value, which is index 1. And so that'll give us the actual value in the table. So now I can get the items for age and date of birth, and we're able to get all our values. So now that we have collisions, we can still hold all of our data in our table using this technique. Now the only difference is if we look at what our table looks like, you can see now it's an array, and then the array has an array inside of it. So for example, let's look at the first element. You'll notice that 3 items collided on the index 0. So we can see first name Bob, last name Tim, date of birth, and the value. And so what we do is we then get this array and we loop through it to find the element, right? So you'll notice if we have a very small table, we're going to have problems because we're going to have a lot of collisions, and stuff like this is going to happen. So usually what you want to do is you want to have a large table that will fit all of your data. So we can pick some really big number like 2000, right? And again, this should be prime. I don't know a prime number. Maybe this one is prime. This is just a total guess. Now, one other thing that's going to come up, and I guess this is like a nice place for a hash table where stuff is working. But there's one other thing that sometimes comes up, and that's what happens if you want to resize your table. Because I did just say, if we have a small table like this, you're going to run into problems, right? Because we're going to have collisions and whatnot happening all the time. So one thing that you can do here is you can keep track of how many items are in your table. So num items is equal to 0. And then every time we set an item, we can say num items plus plus. Now this, I guess, kind of tricks us because I guess it's a new item. Well, I'm wondering how I actually want to implement this, because I'm thinking if I implement like this, we increase the number of items every time we do plus plus, then I can just say set item first name twice like this, and then that's going to say I have 2 items in the table, but it actually shouldn't be like that. I think how I want to handle it in this case is check if we already have the item in the dictionary or the hash table, and only increment it if I do. I think in this case I'm just going to keep it simple and leave it like this, but I think that's what you would do if you want to handle the case I just mentioned. Anyway, we can keep track of the number of items that we have here. And so there's this thing called a load factor when we're dealing with hash tables, which is basically the number of items. Actually, we can just stick in here, I guess. Load factor is equal to num items divided by table.length. All right, something like this. And so the closer you get to 1, the more full your table gets, of course. And then when you get over, it gets pretty bad. And so you can do something to where, like, once you get to like 80% of your load factor, or the load factor is around 80%, you can then resize your table and increase the size. And this will give you a better performance or a better spread, because you're now not going to get the items. Because one thing, I don't know if I went over this explicitly, but the reason why I'm saying performance there is you notice we're having to do a dot find every time we get an item now. So if this array is long, this could possibly be worst case O of n, right? Because it's possible we collide on every single item that gets entered, and we take n time the total list of items we're storing here. Okay, so last thing that I wanted to mention with this is how you actually resize. We have our load factor here. We could check, and by the way, you probably want to recompute the load factor every time we do num items, but this is just to show you the formula. So one thing we could do here is we could say if the load factor is equal to this dot num items divided by this dot table dot length, and we can say if our load factor is greater than 0.8 or 80%, we want to resize. And you'll notice we're checking this on the set item here. This is like a random side effect that will sometimes happen. Now let's write our resize logic here. So the idea with resize is we just create a new array of double the size. So I'm going to say, and sometimes you'll also increase it a little bit if you want to get to a new prime number. Like when I double this, it'll take me to 6. You could increase this to the next prime number and go up to 7. So some algorithms will do that. We're going to keep it simple and just double it. So we're going to say new table is equal to table.length times 2. So here's where resizing gets a little expensive, because notice we've changed the size of our table. And if we look at our hash function up here, we take the table size as a function or as a parameter. So if we change this value, the hash is going to change. So we have to rehash every item in our table. So we're going to have to loop through and do that. So we're going to call our resize also with our set item here. And do this .table first. All right. So now let's go ahead and do that. So we're going to loop through. So we're going to say this .table . I did a for loop up there. Let's do a for loop again and keep it consistent. Nah, I changed my mind. We're going to do for each. All right, so this is going to be item. And remember, our items are actually arrays. And we also need to do an if statement here. So if item. Because sometimes we may not have a key at this, or there may not be anything at that position at all. It could just be an empty. So that's why we do an if here. And then we're going to say item dot for each. Right? And we're going to do for each item in the array, this is going to be a key value pair. So key value. And we're just going to say new table. And again, we're going to get the index, and we're going to do something similar to what we do in set item, right? We're going to compute the index with this function. The difference here is we're going to pass our key in. The difference is instead of this .table.length, we're going to pass in our new table length, which is new table.length. And so here I'm going to pass the index and store the value. And there we go. But you can see now we are doing a for each inside of a for each to loop through every item. So if our items are, if we have 100 items, we're looping through 100 items to put it in the new table. So there is some expense to this. All right, but now let's see this in action. So we have this table of size 3, and you'll see here we are automatically resizing if we hit this load factor. So if we come down here and we look at this stuff, we can see nothing's changed where we store the values here, but underneath the hood, if we look at this, I guess we should just do dot length to see how long it is. So it's length 3. I actually would have thought this resized itself, so I'm wondering if something went wrong. Let's go do a little debugging. So we resize this whenever the load factor is this, and we're increasing num items here. And this is the length. So let's just see if we ever resize happening. So with Quokka, I actually don't know if this tells me when it's running the code, it actually resizes it twice. Oh yeah, I'm just a noob. In a resize function, we didn't actually set this .table equal to our new table. There we go. There we go. Quokka is now working nicely for us. I was like, this looks like it should be working. And then, yeah, we just didn't assign the variable. So now I'm going to print the length. All right. And is it, dot length doesn't evaluate into anything. It's table.length. And it's not printing anything. Did we infinitely loop Quokka or something? This .table.push is not a function. Oh, we have a little bit of an error. That's fun. Oh yeah, I'm a noob. So this is our noob moment. I just set the value here. This is what our old version of it looks like. We need to do this. And we could probably abstract this bit out maybe into its own function, but I'm going to copy paste for now. All right, there we go. So just like in that other place, we can't just stick the value at the current index in our new table. We have to store it in an array. So this will be new table, new table. There we go. And now let's see if that still crashes things. Nope, looks like it's printing it out now. Perfect. So what I wanted to show you is, notice how the length changes. All right. So we started with length 3 when we added a first item. Then we added a second item here, tem. The length is still 3, but then when we add the age, we now bump past the load factor. And so now the underneath the table is actually resizing itself to 6. All right, and it just did that without us even having to know about it. But there you go. That is implementing a hash table in JavaScript. Now, one last thing that I thought I would mention with this is you'll notice there's some decisions you have to make when you create a hash table. So there are some times, well, I've never actually needed to implement my own hash table, but just note underneath the hood, there are some decisions that people are making when they implement a hash table for you. They are picking the hash table or the hash function, and they are picking an initial size for the table. Let's actually put this back to a larger number now. There we go. Maybe not that big. And so that will affect how your table performs. right? Depending on how many items it's actually storing inside of there. So that's just a thing to note about this table. So keep that in mind next time you are using an object over here, that this is actually going to be storing the values in an array underneath the hood. So that is pretty cool. I did not do this correctly. Oh well. If you like this video, make sure to give it a thumbs up and don't forget to subscribe.